intimate, and so we'll just have that conversation. I'm going to start by just asking Professor Masters, some stuff, and you can answer a couple of questions, and then we'll go from there. All right. And this is about a book called 30-Second Space Travel. I think Alan has a copy and is holding up the book right now. And this is a book that the three of us wrote together. Yes, Karen has one too. I myself do not. That's okay. It's better that I don't multitask. Hello, Myrna. Good to see you. So the question that I first want to ask you has to do with the fact that we are actually not astronauts, right? You and I are astronomers, astrophysicists. We're the scientists that study space. And I'm curious to know, for you anyway, was it space, like a love of space, that drove you toward astronomy as a career? Or was it your love of astronomy that has driven you toward thinking about space and space travel?
Yeah, I think like many young people, I didn't really understand the distinction when I first started getting interested. I just thought space was really neat. I really liked it. I was really interested in anything to do with space, astronomy. And as I started to learn more, I realized just how big space is. And so, astronauts get to go into space, but they don't really go very far. You can't explore the distant universe as an astronaut. And in fact, probably that's never going to be something we can do. And I found I was more interested in what was, really out there. And so the best way to study that is from the ground, rather than being an astronaut. And I sort of learned that astronauts in particular, they have to become incredibly specialists about the rocket that they're flying in. They have to know all of the details. They have to be incredibly unflappable. And it's just a very different set of skills than being a researcher. I think I would be quite flappable in space. And I wouldn't enjoy having to learn all of the really specific details about what all the different buttons do and things. So I think while it would be really neat to go into space and experience weightlessness and get that view of the Earth as an entire planet and, see the stars without an obscuring atmosphere, for a job, I find, being an astronomer and being able to study the things that are much further away than we can ever hope to visit as astronauts, that for me was that's what kept my interest. And so that's why I pursued that.
Yeah, that brings up, a really good point, Karen. And that is that we talk about rocket science as being like a euphemism for complicated things. Oh, that's rocket science, or that's not rocket science, right? But really, a lot of what we call rocket science is built on some basic physics, scientific principles, and the connections of that. These are the things that we teach to our students all the time, right? Talk a little bit about that. Your connection, like between what we say rocket science and what was really basic science.
Yeah, I mean, it's funny, right? I have this memory of a family member boasting to someone that I was really a rocket scientist, which is, and it's like you said, it's kind of code for it being really hard and being, that person's really smart. And I can see, I teach introductory physics at Haverford, or I have the last couple of years. And I can see a lot of the students sort of lighting up when I say, okay, now we're going to talk about, the physics behind launching rockets. And we're going to talk about gravity. And we're going to talk about all of that stuff. That's, for many of the physics students, that's the thing they're really excited about learning in an intro physics class. I mean, we should probably acknowledge physics itself, has this kind of coding as being something that's very difficult. Like, it's very common when I interact with people, if I tell them I'm a physicist, that they'll say, oh no, that's very difficult. I hated physics. I dropped it in high school, things like that. So I have this real passion for trying to talk about physics in simple language and, explain how it underlies everything we do. And yet also it helps us send astronauts into space and do all this cool stuff. So I think that's really important sort of connection that, I was making a pop rocket with my son today. He's 11, and doing a virtual astronomy camp this week. And so that, it's really easy to make a rocket. It doesn't go very far, of course, but the basic principles of how rocket work are something that it's not hard to recreate. What's hard, of course, is getting a rocket that can get out of the gravity of the Earth. But I don't know. I just like that connection that it's just the stuff that's all around us, and yet you can also use it to get out into space.
Very, very cool. Okay, well, let me let you, Karen, if you've got something to ask either me or Alan, go ahead and pick one, and
Sure.
we'll go.
I'm going to start with Alan since
Okay.
since he hasn't had a chance to say too much yet. And so I remember once Charles explained to me how, it was fantastic that you were involved in writing this book, because you're really an expert on kind of the early history of rocketry and a lot of that background, but also sort of the the stuff, the futuristic stuff, the stuff that's going to be coming. But I was going to start with the early history of rockets, and maybe you could share one of your favorite stories from, ancient rocketry and the sort of development of what we use now to go into space.
Yeah, so basically the first rockets were black powder rockets. So gunpowder was the first explosive developed, and also was thereby the first rocket propellant developed. So a lot of the early amusing or interesting stories from the early days of rocketry are stories about people doing weird stuff with gunpowder rockets. So for instance, there's one story that was mentioned briefly in the first of the sections in the book, where one Ottoman writer wrote about a mysterious event that seemed to have occurred around 70 or so years before he was writing, where he said that there was a experimenter who was so excited about the fact that his rockets were flying very far that he decided to strap himself to one and fly into the Bosporus. I presume he wasn't aiming for the Bosporus, but supposedly he survived as well. So that's heartening, at least. But yeah, so that the idea that, like, as soon as we come up with this technology for rockets, we're like, where can we take them? We want to, go as far as we can up into the sky. And I'm glad that today's astronauts are a little bit more prepared for their journeys than strapping yourself to a gunpowder rocket with wings and flying into the Bosporus, but surviving supposedly. Now, I don't know if this is true at all. Like, this is one of those things where it's like a writer claims that another writer claims that a third writer claims that this guy did it. But
even today, though, it's astonishingly dangerous, right? To go into space. And I always think about that every time I watch a televised launch,
Yeah, definitely.
Cool. And so, sort of speaking of televised launches, this past weekend, Virgin Galactic made had a live stream of this first commercial flight just to the edge of space, a suborbital flight. And I remember being really struck. There was this claim that efforts like that are really going to be opening up space to everyone. So opening it up beyond a select few. How long do you think it'll be before space travel becomes routine?
Yeah, so for people who have either missed this or just saw this tangentially, we just this past Sunday set the record for the most people in space at once. There were 16 total people in space. So there were 7 on the International Space Station, 3 on China's new space station, and then 6 in this private suborbital rocket. So this rocket that was launched from an airplane just poked itself up just past the edge of space, just above that 50-mile line that the US Air Force claims is the edge of space, and then came right back down to land on a runway. And so this was Richard Branson's brainchild and funding project. And so he was sort of in a competition with the other billionaire, Jeff Bezos, to see who can get up into space first. Jeff Bezos is planning to launch next week instead of this past Sunday. So Richard Branson got a little bit of bragging rights.
But Bezos is going to orbit, right?
Bezos is not going to orbit, but he's going a little bit higher. So he's going still suborbital. So still just up briefly and then back down. But he's going
a little bit further. I remember,
just a little bit higher, above the 100-kilometer mark, which is the international definition of the edge of space. Yeah. So, I mean, obviously, the fact that space is it's definitely expanding the access to space, and it's not just going to be for the billionaires that are building these rockets. Eventually, the plan for these specific rockets is that they'll sell seats aboard for maybe $500,000 or something that is a large sum of money, but not an absolutely insane sum of money, and would enable people to go on these space flights. But what's exciting to me about this isn't just the fact that now wealthy people are going to be able to go to space more often, which is just exciting enough itself, but that the technologies that they're developing, so things like hybrid rocket engines, which is a technology that Richard Branson used on his space plane, and the reusable engines that Bezos is using on his rocket, are going to make it so that people with scientific or commercial payloads, so little satellites, will be able to send those into space and do their research or do their commercial enterprises much more easily. And so I think in terms of the actual number of years it will be, it depends on how routine you mean for it to be. If it's for access to space to be as routine as, say, access is to Antarctica right now, that might take just a ballpark number, 40 or 50 years. But for it to be, it's not just going to get there suddenly, it's going to get there slowly and over time. And I think that learning process is going to be very exciting.
So you mentioned, one of the ways space is opening up is growing numbers of satellites orbiting Earth, so not just people going up into space. So I'm actually going to ask Charles a question from his perspective as an astronomer. Astronomers are really worried about this growth of very large numbers of satellite constellations being launched. I think Elon Musk is responsible for one of the largest satellite constellations, speaking of another billionaire chasing space. As astronomers, we're worried about that obscuring the night sky and basically making it harder for us to do our research. So outer space, it kind of just makes me think about how outer space is a resource. And I wondered if you wanted to sort of talk about how you think we should be sharing this resource, which is access to outer space.
Yeah, let's talk about that. I find this kind of in a couple of ways, right? One, indeed, you, Karen, as the spokesperson of one of the world's largest collaborations in astronomy, the Sloan Digital Sky Survey, you know better than I do what a threat all of these thousands and thousands of proposed satellites is to nighttime astronomy. Even now, if we're trying to take an exposure of the sky, it's not at all unusual to see several streaks of light cutting across our images after we finish our integrations because they were caused by satellites. Now, the Vera Rubin Observatory, which is going to be monitoring the sky at very high rates over the next decade or so, has actually had conversations with SpaceX. Now, the folks have said, look, if you're going to do this thing, we're going to be really messed up. Can we find ways, A, to make your satellites more innocuous to astronomy, or B, at least say, have schedules, allow us to be able to track where they're going to be when, so that we can aim our telescopes in different spots at different times. So it's really going to be a public-private partnership to some extent to sort of be able to coordinate these kinds of things. On the larger scale of space as a resource and so forth, I think about space these days and the space between us here on the ground and up high in much the way that we might think of the electromagnetic spectrum 100 years ago. Alan actually knows much more about this than I do. Alan is a ham radio operator, but from about 1920, 22, 23, something like that, right before the first licenses were being granted by the Federal Communications Commission, which just was formed when Herbert Hoover was Secretary of Commerce or something, Alan?
Yeah, something like that.
Yeah. There was a vast explosion of people broadcasting in the radio frequencies. Today we would call them pirate radio stations, but back then they were just radio stations. And they just broadcast everywhere and all the time. And the electromagnetic spectrum was crazy. You would try to turn on one radio station and all these others would be crowding and no one could do anything. And so finally, in the mid-1920s, the Federal Communications Commission was established by Herbert Hoover. And as a result, we wound up having this well-regulated AM/FM radio system that developed over a period of decades. And that system came out because of World War I. When people were first starting to use communications in wartime, after World War I, the United States government had some restrictions on what band passes people were allowed to use non-militarily. But they made a mistake because they thought, well, there'd be only certain parts of the radio frequency that are useful and all the other parts were useless. Little did you know that innovative radio people could use any part of the electromagnetic spectrum that's allowed. And today, of course, we have to have even more careful regulation because of cell phones and things like that. I think space is going to be like that. And we have to worry even more, referring to the World War I thing, about the militarization of space, which seemed to be in check for a period of time during the Cold War when there were really only two entities that regularly sent stuff into low Earth orbit, US and the Soviet Union. But now we have many, many such things, and they have the ability to send up thousands of objects with relatively small cost. And at the moment, it is the Wild West out there. There is no regulation, there is no communication. We need to make that happen. But will people be willing to talk to one another? It's my hope that that will happen. But an appeal to the public will be good.
It's an interesting analogy for me. So I don't know if I've mentioned this to you, Charles, but I'm on a committee where we're basically trying to keep track of the radio astronomy allocations from the radio spectrum. And so this is something I've actually been spending some time learning a bit more about the regulations. And I mean, I think it's one of the reasons I've gotten a bit worried about satellite constellations, because in my experience, companies do what they have to do. They don't tend to do things out of the good of their heart. And so can I screen share? I have this, this is the color coding in this diagram. This is the electromagnetic spectrum that counts as radio. And the color coding shows all the different allocations. And so it's very, very tiny, but I can draw a circle around it. This yellow here is radio astronomy, and don't be fooled by the other yellow. But radio astronomy has these tiny, tiny allocations, like here, that's not radio astronomy. And down here, there's a bit more. And yet we're still having to battle to keep those, all the wireless devices everyone has, particularly high frequency. 5G is a relatively high frequency radio thing. So we're constantly, we get the FCC kind of, people asking for more frequency spectrum. And when we say, no, that's the frequency that 21 centimeter line from hydrogen atoms emits at, you can't do it there, that kind of thing. I mean, that's actually a trivial example. That part of the spectrum is highly protected, but it's a very narrow part of the spectrum. But anyway, so it's just interesting that you made that analogy, because it's quite a battle in the radio spectrum. So it'll be interesting to see how it goes for access to space.
Well, anyway. Thank you for fighting the good fight there, Karen. I know that radio astronomy absolutely needs that.
Yeah, it's been quite interesting to learn about it. It's a very different kind of set of skills than we normally use, because it's much more about arguing legally and politically, rather than it doesn't matter what the physics says. What matters is what you can get through the regulations. It's really interesting. Anyway, back to the book, and another question for Charles. And so, you approached me about this book, I think, if I remember correctly. And so I wanted to know, what appealed to you about writing about space travel and putting together this team to write the book?
Well, I could not think of anyone better than you, Karen, to work with on this. We worked on 32nd Universe together, as you know, and that was so much fun. And we really understood each other, like we're on the same wavelength, so to speak, as we're talking about electromagnetic on what we're doing. You and I, we have, for the audience that don't know, we have very similar scientific interests, but we approach our interests from different directions. You are very strong in doing the radio astronomy and in these large surveys and so forth. I like looking at individual galaxies one at a time and trying to see how they, just like cells in a human body, you can sort of reflect the entire body as a whole and its aging processes and its overall activities and so forth. But together, we've really done a lot of fun stuff together over the years. And ask not for whom the bell tolls, it tolls for thee. Okay, we'll let it ring 7 times and it'll go on. Thank you.
Your clock is ahead of schedule.
Yes, it's a few minutes ahead of time, everyone. Don't panic. It's not
ready for the, what is that called, Alan? They pause the countdown.
Yes.
before
Oh, the
launch.
leap second.
No,
Oh, no,
I meant when they do the countdown, when they're going to launch a rocket, they have
oh yeah, and then they have the
hold.
pause. Yeah, the launch
Yeah.
hold.
Mhm.
Yeah, that too. Oh yeah, those are both interesting things.
Right. So the feeling for me was that we did that book 30-Second Universe, which was talking literally about cosmology, right? And the 30-second series is published by Ivy Press, which is a UK imprint. And they really liked how we did that. And so what was next? What would they want us to do next? And the idea was to do something exactly the opposite. Instead of going all the way out to the very earliest history and thinking about the largest things and then so we're good. Instead of thinking of all those things, why not think about what's right nearby? Right? We think of outer space as being out there, but really, just as Alan was saying, right? The Air Force in the United States defines outer space as merely 50 miles above Earth's surface. The international agreement is only about 62 miles. The International Space Station is only about 240 miles above the Earth's surface. And whereas you and I, of course, the closest objects we talk about are millions of trillions of miles away. And that's just the nearest galaxies. So why not look right there and look at how we humans are coming outward to meet the universe, the way that we were studying the universe from without and coming in. So that was where I really thought that this book would work very well. And then, our good friend, Jonathan McDowell, who was probably in our field the most knowledgeable about space amongst our friends. As you may recall, we approached Jonathan and said, "Hey, you want to do this with us? Because we need 3 people to be able to do this well with the proper." And Jonathan was too busy. Poor guy. Those of you who don't know Jonathan McDowell's work, look on his blog. You can find him at the Harvard-Smithsonian Center for Astrophysics. Just amazing about space science. And then,
if you ever want to know what's in space and what's going to fall down, it's Jonathan is the one you want to ask. He has this amazing database where he tracks stuff. It's really cool. Yes.
So everyone jot that down. Those of you who are in the class there, Jonathan McDowell. So how are we going to do this? Who is the good third person to go? And Alan came to mind right after Jonathan, because Alan's knowledge about space is remarkable, and tremendous interest, and a great science communicator. And so I asked the Ivy Press folks, "Hey, can Alan be the third author to join Karen and me?" And they said, "Sure." And here he is, and we're really happy to have that. So this is how this book ultimately came together, and Alan's sort of expertise, as you pointed out, about the history of rocketry and where it came from the ancient times through World War II to Sputnik and the early Russian and the early American up to the present time. Just tremendous knowledge. So I was really happy. So that's how this book came together, and hope that everybody kind of enjoys that view of space instead of just all of space and time. We just have a little tiny bit of space and time that's kind of right near the Earth.
It's a very exciting piece of space and time.
Yeah, because we're in it, right? Yeah. All right. Hey, Alan, you want to ask Karen's couple questions just for fun?
Yeah, sure. So here's a fun one. So one of the people going to space alongside Jeff Bezos is going to be Wally Funk of the Mercury 13 fame. So what do you have to say about that? So I heard about that. It sounds pretty exciting.
Sounds pretty cool. And I mean, she looks delighted that she's finally getting to go into space. So Wally Funk was one of a number of women who were selected as astronauts very early in the US process. So they're part of the Mercury 13 who followed the original Mercury 7, right? The original set. And what was really interesting, and I think I'm just going to go with this, and I think this is really awesome, was that a number of these women in the Mercury 13 outperformed the Mercury 7 astronauts in the tests. They were put through the same set of tests as the Mercury 7, and outperform them. And Wally Funk in particular outperformed John Glenn, who was the first American to orbit. Yes, outperformed him in a number of the tests. And yet at the time, the program was just cancelled. They decided they didn't want to send women into space. And in fact, it wasn't until the 1980s with Sally Ride that the first American woman went into space. Despite the fact they outperformed the men on all of these tests, someone in the higher up was just like, nope, we're not going to send any women. So I'm excited for Wally Funk that she gets to go to space now. I'm sure, you know, she's been waiting for this for decades, right? I think that's fantastic. I'm sure she'll have a great time. It's a bit of a shame that it had to happen this way instead of her earning. I mean, she definitely earned it, right? She was ready to go into space when she was selected, but political or whatever reasons prevented it at that time. So I'm really pleased she gets to go now.
Yeah, that's really great. It's really great to hear that story. Do you think so? If people who are, you know, now people in their 80s are going to space, like Wally Funk herself, do you think we should all plan to travel to space eventually at some point?
Well, it's interesting, right? And I like the analogy you made about Antarctica, right? Like, you know, it is possible to go to Antarctica. I actually know a handful of people who've been, mostly because they've been involved in scientific research. But it's not easy. It's incredibly expensive. I think you can go as a tourist, but again, it's an expensive trip. I think your time scale that, you know, substantial numbers of people are going to be going to space over the next few decades sounds about right, but that's not going to be everyone, right? It's not going to be hundreds of thousands or millions of people. It's probably going to be more like hundreds of people. So much as I would love to live in a universe of like The Expanse, the television series, I like that show, where, you know, it's just routine to be in space and going, you know, I think it's probably not very plausible in our lifetimes, which is a shame. But so my guess is I will never get to go to space. I don't know if that's defeatist, but don't you think?
I am optimistic that when I'm Wally Funk's age now, that I will be able to get up there, feeling confident that I'll get back down again without too much trouble.
Yeah, that's a very important part of it.
Yeah, coming back does seem important. Yeah,
like mountain climbers too, right? An experienced mountain climber once told me that a guide told him that you can go up a mountain anytime you want, but if you want to come back down again, you better be careful whether you go up or not today. Right? Very interesting stuff. Okay, so everyone in the chat, let me tell you all, please start adding your questions now into the chat as I ask one final question. I would love Alan to address this because Alan is so knowledgeable about the latest and the coolest stuff that's happening. And we'll use this as a springboard for conversation for all the rest of you. Please, like I said, treat this as you're sitting in a room with us. Well, you are, right? It's a Zoom room. And any question you want to ask about space travel or that kind of thing, astronomy, whatever, we're here, we're able to provide them. So let me ask you, Alan, what current or developing technology are you excited about that will actually get us back to the moon?
That will get us back to the moon specifically?
Well, that can be specific, but elsewhere, yes. That's what I'm thinking about most, right? But
that's fair. It's an exciting destination, definitely. Yeah, so I think really reusable rockets are, you know, the space shuttle was the first reusable rocket in a lot of ways, but it was more refurbishable than actively reusable on a regular basis. It would take you know, as we learned with the shuttle disasters that happened in the end, that it was a hard process to actually undertake, and it was expensive to make the space shuttle able to fly again. So the fact that we're now getting rockets like the Falcon rocket, that's Elon Musk's rocket, they're also planning to do this with Electron rocket, the small one by Rocket Lab in New Zealand that I mentioned earlier. They're planning to have single rockets, or at least parts of rockets, large parts of rockets that can be reused fairly rapidly. I think that, so for instance, NASA's partnering with SpaceX to use one of those SpaceX's new reusable rockets as the lander portion of the part that will actually go from their new moon orbiting space station that they're planning to build to the moon itself. And they'll be able to reuse that several times over and over again. I think that will make it so it's not just what we call flags and footprints, where you're going in and you're planting your flag and you're saying we've been to the moon and grabbing a few rocks and then never coming back. Whereas it's going to be something that can actually sustain for a long term and do some real ongoing research and space development and stuff like that. So I think really that reusability is going to be key going forward.
Sounds great. I love that. Yes, and fully fits within the reduce, reuse, recycle philosophy of the 21st century, right? Which we all
definitely.
Okay, great.
I mean,
so
can I?
Yes.
If I could just add one thing, I'm particularly excited about the idea of radio astronomy from the moon. So because the moon rotates at the same rate that it orbits the Earth, it always shows the same side towards the Earth. So the far side of the moon is shielded by the entire moon from all of the radio emission that humanity makes. So that causes some challenges, right? But for radio astronomy, that's an incredibly quiet place. And so if we could get regulations to try to keep that part of the moon relatively quiet from radio emissions, we could do some really cool radio astronomy from the far side of the moon.
That's great. But isn't there already some radio noise on the far side of the moon right now?
Yeah, well, so there's orbiting satellites around the moon, and of course, and if there's a moon base, you are going to want to be able to communicate around the moon. And so there's going to have to be some satellites around the moon for communications and relays and things. But if we could regulate them to be in a very narrow part of the frequency spectrum, I think radio astronomers would be very happy.
Very cool.
Yeah.
Thank you. So here's what we'll do. Maurice, being the master of ceremonies, you can start getting people to answer questions. And all the rest of you, think of this as being in a classroom with Professor Masters and maybe Professor Me. We're going to call on you if you don't put a question in yourself. So iPhone Is and Jasmine Valley and Jeff Opera Addict and Gene Chapman and Myrna.
I see what your classes are like, Charles.
Oh yeah.
Oh yeah.
Everybody's questions get answered. So often people are worried about asking stuff. Oh, we already chased someone away.
You scared someone away.
No.
Oh no.
We want you to come in and talk to us, ask your questions. This is what we want. This is the fun time to do this. So go ahead and do that. All right, everybody do participate and no pressure. We really just want you to have fun with it, okay? All right, go ahead, Maurice, talk to us.
Well, I have a question from a familiar person to you, I believe. Amy Brad Blue wants to know, among the three of you, do any of you wish to go into space if the opportunity presents itself? You guys, I guess, talked about this a little bit earlier. And in what manner would you like to be in space?
If I were to go to space, I would totally want to go wearing a suit that has its own little rocket pack and go around like that one little dude going, woo, myself, and have a really big GoPro right here where I can take the pictures of everything, go, wee, and then have something like grab me and stick me back into the spaceship for landing. That's how I would love to go, if that were possible. If that were made safe, like as safe as, say, scuba diving, I'm all over that.
Yeah, definitely would be excited to go to space. I'd like to be like someone asked me if I would want to be in the first 10 people on the moon or on Mars or something like that. I'd be like, no, but I maybe want to be the 10,000th person somewhere, where it's a significant milestone, but there's enough people there that it's cool. We know that you're going to come back okay. We know that you're gonna do everything okay. But yeah, even just going on one of those little suborbital hops would be cool. But actually being able to hang out and do stuff in space and get some cool science done, that would be the best way of doing it for me.
Even one of those parabolic flights where you get to experience weightlessness.
Yeah, those are cool.
The problem is I get pretty motion sick, so I'm pretty sure that I'm not gonna feel good.
Well, it's no accident that the NASA plane that was used to teach astronauts how to survive in zero G is called the Vomit Comet.
Indeed, yeah. So anyway, I like Alan's answer that it's got to be safe. I think I also wouldn't really enjoy launch very much. So if people could invent teleportation or something, so I could just magically be in space and enjoy the view, that sounds good. I was always quite attracted by this idea of space elevators. So this is the idea of you get some incredibly light, strong material that you can connect from the ground to a geostationary satellite, and then you can basically drop a weight down one side while lifting a weight up the other side. And it's a very low energy way of getting to orbit, if you can find the magic material that can actually make this connection, which doesn't exist, by the way. But a space elevator trip sounds like it would be okay. I'll do that, not a rocket.
Does anybody want to live on the space station? Nobody wants to live on the
That'd be
ISS.
interesting for a while. Yeah, I mean, I could probably handle it for a few months, probably
Like
not
a
much longer
week.
than that. Yeah.
Like a week.
A week.
First I'd have to,
Yeah.
vomit everything out of my system. Right. So I just get everything all covered. Like
They
all
feed you the low residue diet, right?
low residue.
That's what they
diet.
call it.
I mean,
Yeah.
astronauts have this problem, right? They get space sick. So
Right.
Yeah.
Well, I would love to be up there, especially like I said, if I
Yeah.
could just have a camera and just take pictures all day long from that little observing bubble there. I could do
Yeah.
that all day.
like to go in. What do they call it? The gondola. I'd like to sit and look
That
at
would
that
be
view.
cool.
That would be cool.
Jacqueline Meziani, hello, hi, thanks for joining us. We're getting
Hello.
hi.
Hi.
And
I wanted to thank you for calling me out.
yeah, go for it.
I thought you were just I thought you were bluffing, but
Oh,
I do,
well,
but I do have a question. Actually, in terms of like either elementary or middle school or even high school education, how much effort, or do you see any progress in more teaching of space or astronomy, to children? I mean, I don't remember my kids ever talking about it in any class that they took, but is there any current push to learn more about space in schools and add that to the curriculum?
great question. Yeah, Karen, you have children who are still in the
Yeah.
K-12 system?
That's right. Yeah, my son just finished 5th grade, and they had a space section. I think they often do it as a sort of, environmental earth sciences, and there's a little space section in there. In terms of in the sort of high school type education, it's usually a part of physics. It's not the whole of physics, but there's going to be some amount of covering gravity and orbits and some of the basics of sort of astrophysics in a physics class.
I could see making it part of the environmental awareness, because it's really fascinating.
Yeah, if we grow environmental science to include low Earth orbit environment or Earth moon environment, that kind of thing. I think
but it is the environment that we live in, right? I mean, it's being familiar with the phases of the moon and things like that is all part of being familiar with the natural world.
Yeah, and we observe Earth from space too. And that really helps us with our environmental awareness.
But it's also, the poor teachers have so much content. How do you support the teachers to be able to teach it?
So astronomers work pretty hard at this. So I've been involved in a number of initiatives where we try to make resources available and free. In the Sloan Digital Sky Survey, we actually spent quite a lot of time trying to connect them to the, I've forgotten the name for it, but the sort of the standards, right? The science standards. There's many, one of the things I love so much about astronomy is there's so many connections to different areas of science. So while you might not take a class called astronomy, you are learning things that are important to astronomy, or you can connect what you're learning to astronomy in some way. And so, there's places to put astronomy into the curriculum without it being called directly astronomy. And there's a lot of free, because of NASA, because of, astronomers just being really passionate about their subject, there's a lot of free material available for teachers.
Good. I hope teachers are aware of that.
We try, right? I mean, so that's always the challenge.
Campaign.
Yeah, that's right. That's a big challenge. Both Charles and I have been part of the American Astronomical Society Education Committee, and one of the roles of that committee is to try to connect, teachers and connect astronomers to, support astronomers working on education.
Fascinating. I didn't know, so I'm glad. That was a good answer.
Thank you. Yes. by all means, if you want more of that information, talk to Karen afterwards. We'll send you all the links and all the stuff that you need. It'll be great. Thank you. See,
Thank you.
no bluff, and really glad you're participating. Yay! Thank you. Okay, so go
We
on.
have a lot of, we have a lot of questions in the queue here. We have a question here for Alan. Leah B would like to know what you enjoy about higher dimensional mathematics, and two, what is it?
I feel like I should answer the second part first and the first part second. Yeah, so the number of dimensions that we have in the world is sort of the number of directions that you can go and the directions that describe the size of an object. So if you drew a square on a flat piece of paper, it has two dimensions. It has a length and it has a width. And in our universe, as far as spatial dimensions are concerned, that's the dimensions you can walk around in or jump around in. There's three: you have length, and you have width, and you have height. And then Einstein and people like Lorentz and sort of friends like that said that time sort of acts as a fourth dimension because you can talk about things existing for intervals, and you can sort of convert between them using Einstein's laws of relativity. So one thing that I did sort of in my college thesis actually was talk about if instead of having just three directions that you could walk around in, if there were four, if you could just imagine through our powers of mathematics and our imaginations, what would life and shapes would be like if you could go in a fourth direction perpendicular to length, width, and height. And so what I really enjoy about that is that it's sort of, you get to think about the way a universe could be that you can never actually visit yourself, something that you can, it's just really cool to me that you can think about this and do coherent mathematics in this sort of weird universe. It's almost like entering an alternate dimension from a TV show. So that's what I really enjoy about it. And I think there's a lot of cool applications you can talk about this in terms of things like signals processing and some other weird stuff that you won't immediately think of when you think about dimensions, but even just the abstract part of it is very fun.
Just imagine a four-dimensional triangle.
Yeah, so a three-dimensional triangle is a triangle. It's got 3 points, and then a two-dimensional triangle is 3 points. A three-dimensional version is a tetrahedron, which has 4 points, and a four-dimensional one would have 5 points. It's kind of whack. Yeah, this motion is like 2/3 of the time I'm continuously doing this while I'm studying this stuff.
And you learn that in college, exactly?
Yeah, so I studied that for my senior thesis. So I studied that with a particular professor, and we dove pretty deep into it, and it was pretty fun.
Wonderful. We have another question. This be for all three of you. Is it a coincidence? This is from Michael. Is it just a coincidence that the moon rotates at the exact same frequency that it revolves around the Earth, or is there a physics reason why that happens?
You want me to answer? Yeah, it's actually a really cool physics reason. So I'm really glad that you asked the question. You've heard of tides in the ocean, right? So the tides are related to the moon. And basically what's happening is that the near side of the Earth is pulled towards the moon by the moon's gravity, a little bit more than the center of the Earth. And the far side kind of falls behind a little bit, it's a little bit further away. And so the whole planet Earth bulges a little bit in the direction of the moon. And we don't really notice it with the ground, but the oceans kind of slosh around. And so we see it with the oceans. So the moon's doing that to the Earth. Meanwhile, the Earth's doing exactly the same thing to the moon. And over hundreds of thousands of years, that slight elongation basically was kind of like a lever and kind of basically fixed the system so that the moon would rotate at the same rate that it orbits the Earth. So the moon continues to move slightly away from us as it takes energy from the Earth's rotation. It's slowing the Earth's rotation down a bit. And so in the very far future, you would also have a case where only one side of the planet would see the moon. Turns out if you do the sums, it's long enough in the future that the sun will have exploded by then. So we're never going to see it actually happen. But it is a process that's ongoing. But the moon's smaller, and so it felt the effects more strongly and has already we call it being tidally locked because it's to do with the tides and it locks the rotation to the orbital speed. So it's really cool.
Michael, did you want to follow up? Yeah, go
No,
ahead.
I just wanted to say thank you. I've always wondered that, and I
Yeah.
never had an opportunity to ask anyone that. And it was, you mentioned it earlier, and I appreciate getting a good answer for that. Thank you.
You're welcome.
Great.
Well, we have another question. I guess we talked a little bit about sort of that idea of pollution in space or space being too cluttered. So Leo has a question. Please share your thoughts on parts of spaceships, rocket ships that are jettisoned as waste in space. Will it ever get too cluttered as all these objects circle the Earth's atmosphere, or will they all float elsewhere, somewhere else in the galaxy?
Alan, you want to take that?
Yeah, sure. So there's it depends on exactly what pieces of things you're talking about, because there's a few different fates that they could experience. So the ones that are just barely in space, so like those 50-mile up or 100-kilometer up things, they'll experience drag from the little bit of the atmosphere that's left. And so over the course of months or years, those will slowly circle back and fall down. So those themselves don't get too big of a deal. And then for the things that are
the Earth, I guess.
they will hit the Earth, and then
Technically speaking,
you have
yes.
to worry about it hitting your house or something like that. There was
Yeah.
a big Chinese booster that did that recently, and thankfully it landed in the ocean, but it was a little bit close to the Maldives, so the Maldives were a little bit nervous. Yeah, it's the things that are over 1,000 miles away from the surface of the Earth. There's just so much space out there that the odds of any of them running into each other or running into your spacecraft are very low. The thing you have to worry about are the ones that are in the in-between zone. So the things that are about maybe 400 miles up, so it's something near the space station, or a little bit farther out than the space station. Those will stick around on the order of years. And if we have too many things there, you could have this problem where two of them will crash into each other. A couple of times this has happened where two old satellites or old pieces of rockets or something like that will crash into each other, making a new cloud of debris that might eventually go crash into something else, and then it'll crash into something else, and then you'll just have a whole bunch of junk out there, and you'll have to wait for it all to come down, or just shoot it down with lasers or something like that in order to get
I've
your
seen
rockets
these
up.
ideas of like going up in with rockets with big nets and catching it all. Is that
Yes.
totally? Yeah.
No, that's not crazy. The idea is there's some, so the nets would work if you know where to aim, and you can exactly steer your spacecraft there and just grab it and bring it down. There's also the laser idea is actually a real idea where if you heat a particular side of the debris with lasers, it'll evaporate, and that evaporating gas will push the debris out of the way and back down onto, nearly the Maldives again. And so there's some ways that we can clean it up if it does get too cluttered, but we just have to be a little bit careful with that intermediate zone before then. And then hopefully someone will go and clean it up. Maybe we can sponsor a space garbage crew or something like that.
Does anyone remember the brief sitcom in the 1970s called Quark? Another example of my useless cultural information from a time that no one remembers. Richard Benjamin starred as the head of a space garbage truck. And it had these big arms that go out and like grab gigantic space bags of trash and pull them in.
That's cool.
I
I watched a modern movie called Space Sweepers. It's a Korean movie where they had all really cool graphics and they were flying around catching space debris.
That's cool.
It was cool. It's in Korean, but that's okay.
Okay, we have the question from Jeff. Last night, Venus and Mars were very close, but it was too cloudy to really see it very well. What do we miss, and what is so interesting about planets being close together in the sky or in space?
Well, and that actually relates to Jeff's, and another question that Jeff has asked below. It's, are there any astronomers who believe in astrology? Jeff, are you cool if like I tried to address both of those at the same time a little bit? So let me do that, and then please, Alan and Karen, chime in if you have any other thoughts. All right, good thumbs up. Here's the deal, right? Venus and Mars being close is cool. All right, I love going out and seeing these things. It's called a conjunction, when two objects out in space are easily visible really close together. And I take photos. I go up into a ridge near our house and we set up this little camera and try to take pictures. And it's just really neat to see. Is there anything physically significant about them? Not so much. And that doesn't take away from how cool it is to me, right? But it's comforting to know that these kinds of space coincidences happen all the time. It's basically, if you think about Earth and Venus and Mars and Jupiter and all these other things going around the sun, all at different distances and different speeds, that if you wait long enough, from one vantage point or another, sooner or later, they will all appear to be right near each other in the same part of the sky. And then throw the moon in sometimes when you have, say, a crescent moon or something coming right up near some planets like Jupiter or Mars and so forth. And then once in a while, we have this thing called a syzygy, where we have numerous objects all aimed in one part of the sky. A few years back, there were 5 planets visible all along the western horizon. It was very, very beautiful. So we're not missing so much in terms of like, is there a physical significance that we could have done? There's some science that can happen when you have something called an occultation. You have an object moving in front of the object, temporarily blocking it. And the result is that you can gather information about the object in the foreground or in the background that you couldn't ordinarily get just by looking at an object in isolation. A deeper meaning about looking at these things, right? Astrology, the idea long ago, back before our modern tools of science were developed, when you see these cool things happening out in space, right? And you're watching it at night because there's no Netflix, you go, wow, that's super cool. And it led the ancients to try to connect, as we humans often do, try to connect things in outer space or things that are unknown with things that we do know. Things, for example, like what the weather will be like tomorrow, or will our crops be good, or will I be able to thrive and prosper by this particular business transaction as opposed to that particular business transaction. And that's kind of how astrology developed over time, right? So today, astrology is like entertaining. You catch it, and if you look in the newspaper or if you look online for your horoscope, which is based on astronomy, right? It's sounds scientific, but you'll find 100 different predictions for Pisces and 100 different predictions for Aries and so on, and they're all different. And that's sort of an entertainment aspect of astrology that I think not many modern astronomers buy into or think that it's scientific. Because really, pseudoscience is like entertainment that's sort of purchased or in the newspaper or otherwise there for us to sort of be amused by. But on the other hand, the idea of thinking about things that are non-scientific is totally okay. There are many astronomers, astrophysicists, astronauts, whomever, that believe, for example, in a divine power or in particular religion or a certain spiritual tradition. And that comes from the realization that science and religion, or science and non-science, are not necessarily mutually exclusive, right? If you know one is one and the other is the other, you can completely pursue science as a career, for example, and yet still have a faith tradition that is non-scientific. You just know that one doesn't necessarily predict or refute the other automatically. So in that sense, I was taught theoretical cosmology by a Jesuit priest. And that person believed very firmly in a divine tradition, in a God that was his belief system. But at the same time, he was doing sophisticated mathematical calculations to try to understand observable properties of the early universe that we can see today in our telescopes, billions of years after the Big Bang. So hopefully that, in a roundabout way, sort of addresses the point. Do astronomers believe specifically in astrology? Not so much. But do we believe in things like astrology where we know that they're not scientific, but yet still provide us with comfort and a sense of place or belonging in an unknown or otherwise mysterious universe? The answer is actually yes.
Interesting answer. And I guess going down to the more carnal needs associated with being in space, can astronauts, this is from Dean, can astronauts enjoy food taste in space? I was told that chefs have to change food flavors for long distance flights to give taste. If food was just Jello, I wouldn't want to go.
So
Hopefully it's come forward
yeah,
since then.
what was interesting is I actually learned a lot about this while working on the book. So I didn't know this in advance, but I think it's really cool. There's something called the Space Food Systems Laboratory. I was looking it up in our book. So there are actual scientists working at NASA working on making sure that the food that's sent up, particularly to the International Space Station, where people stay for many months, I think I know I feel this way. Like if I like food, I like good food. I get really miserable if I just had to eat really bland food every day for months. Even if I could survive on it, that would be really depressing. And so, NASA recognized this, that it's really important for the psychological needs of the astronauts, that they have food that they enjoy, and it's not just Jello. And it all does have to be, long-term storage, and it has to be very contained because they don't want crumbs floating around in the space station and stuff like that. But they put quite a lot of effort into trying to make things that are particularly palatable. So not too long ago, British astronaut Tim Peake went up to the space station. Probably 4 or 5 years ago now. I was living in the UK at the time, and it was a big deal there, right? And it was all in the news that they put together this British specialty, bacon sandwiches, for him to go. And then there's also an Italian astronaut who, very famously, an Italian espresso maker went up with her, and they learned how to make espresso. I'm sure there are equivalents for many other astronauts, but they get to work with this laboratory and kind of work to get some treats and a diet that will suit them. And then I believe every time they have a resupply, they send up some fresh fruits and vegetables because they start to crave those kinds of things. But yeah, it's I think it's a little bit about the environment, right? And it's how it's presented. I think that's also true for airplane food, that you're in this kind of contained environment and you're kind of stuck with what you get. That does things to you psychologically. But NASA and the organizations try really hard to make the food exciting for the astronauts.
I remember reading a while back too, I guess there was an astronaut from Malaysia who had a religious diet, and they create a religious space diet for him while he was in space many years ago.
Yeah, I'm sure, everyone has the specific requirements.
And this is from Ron, I guess the holy grail of space flight now. What do you think of efforts to land people on Mars? When do you think this will be achieved if the efforts underway continue?
Alan, you read The Martian.
Yeah, I was going to say, Alan,
Yeah.
I've read The Martian as well. But
Yeah,
I think
yeah.
Alan's going to have the most interesting answer. So.
Well, I have the most interesting answer. Well, my year guess is going to be 2038 or 2039, whichever one of those has a launch window. I'm not sure if that's going to be made, but that's my initial guess.
Do you want to talk about what you mean by a launch window?
Yeah, so we actually do talk about this in the book also. There's a little chapter on it, that there's, because of the way that Earth and Mars both orbit the sun, you basically have to launch a rocket from the Earth to Mars. There's a particular time of the Earth and Mars's orbits where you have to be so that your rocket will leave Earth and then get to Mars's orbit just when Mars is arriving there. And that happens about every 2 years or so. So there was one, I think so the recent
about 2 years ago, right?
Yeah. So
because they all just arrived in the last few months. Yeah.
Yeah. So there was the Perseverance rover and the Chinese rover and the United Arab Emirates orbiter, and those all arrived at Mars at around the same time because they all had to take this same launch window from the Earth to Mars. And so basically that means that we have these once every 2 years-ish shots to get to Mars. And each time something cool gets sent, and then they'll send back information that'll inform us for the next 2 or 3 launch windows, and then we'll send a new thing and so forth. So in terms of the current efforts, there's a few serious ones. There's the Space Launch System, which is NASA's big new rocket that they're planning to launch the first launch of that in November, and it's based on the space shuttle's technology. There's also Elon Musk and his SpaceX company, which is adopting a different strategy of, instead of making 1 or 2 big grandiose launches, they're flying things and crashing them, flying things and crashing them, and then rebuilding better ones and crashing those. And then eventually they'll get to ones that don't crash. And I think a couple of them have been crashed, have
It's a
successfully
very
made without
traditional
crashing.
way of doing it, right? Isn't that like the early
Yeah.
days of rockets?
Yeah,
They just were like, oh, that one exploded. Next,
Yep.
that one exploded.
Yeah, you could just, I mean,
Yeah.
if you have $1 billion lying around from launching people to the space station on the NASA contracts, then you can afford to do these cool things. And so I think that either of those philosophies, or maybe both of those philosophies working together, will really be what takes us to Mars. And I think it'll be a bit longer than Elon's optimistic time frame, because he always underestimates the amount of time it takes to do things. But I don't think it'll be terribly long. I think 20 years tops at this, if the current efforts continue at pace.
Here's a quick, I guess, follow-up, and very amateur question from me, but is the technology needed for men to walk on the moon, is it radically different than what we needed for like men to walk on Mars? Is the atmosphere that radically different?
So the biggest part is just how long it takes to get there, right? It's like a 3 or 4 day trip to the moon, and it's like a several month trip to Mars. So it's the difference between packing your car for a weekend and packing your ship to cross the Atlantic.
There's also, you get further away from the Earth, so you're more affected by solar wind radiation. And so there's concerns about that, and how people, protecting people from, if there's a solar flare that happens to point in the wrong direction, that could be very bad news for the people who are on their way to Mars.
Yeah, and then Mars's gravity and its atmosphere in an annoying place where like they're just strong enough to cause problems and not strong enough to solve problems. So it's a little bit of a challenging planet, but it's the least challenging of the planets that are not Earth. So
I mean, I guess it's unclear how problematic the dust would be, right? I mean, I've definitely read lots of sci-fi about landing on Mars, where the Martian dust is incredibly problematic and gets in everywhere. And
the moon dust,
we just don't know.
Was very problematic to the moon astronauts also.
Yeah.
So.
Oh, is that right?
Yeah, they were coarse and it's rough.
I remember them talking about metallic smell, right? Because they brought the dust inside with them. Yeah.
Yeah, but it's like sulfurous or weird.
Mars would smell like dried blood. Or iron, right? Fun. That would be pretty nasty. Yeah.
Well, how about burnt hamburger? It might
sound. Oh, okay. That's maybe okay. Fine.
That's a little bit of a nicer way of that.
Yeah.
Well, Myrna has a funny question. I guess she's in the car now. She wants to know how to get her kids into space, but I guess just to get more scientific with it. I mean, I know we're many generations from that probably, but to get like a kid in space, like, how different is it for an adult from a kid? So
we're actually going to go with how you get children physically into space rather than getting them interested in space.
If you don't stop touching each other in the backseat, I will send you to space.
I mean, it's probably just about the scale of safety equipment, right? So the astronaut suits are custom made for astronauts in general, although I once saw a talk by Mae Jemison, who's a very tall African-American woman who went into space. She had very long, slender hands. And she said she couldn't find, like, none of the standard gloves worked for her because the ones that were long enough were too bulky and the ones that were slender enough were too short. So there's already issues with standard safety equipment. I remember there was also a thing where they needed 2 women to do a spacewalk from the International Space Station. It turned out it couldn't happen because they didn't have 2 spacesuits in the right size. So I could see, sending children into space, you're going to need children's size safety equipment, which maybe we're pretty far from. So I don't see that happening anytime soon.
And then you have to make it so that if they have a growth spurt, they don't get stuck.
Yeah.
Well, the latest space suits are being designed to be more adaptive, right? They're using different equipment.
Yeah.
I'm not exactly sure what the technology is. I don't know if it's carbon fiber or graphene or just.
They did look very futuristic. The SpaceX launch people.
Yeah, the SpaceX ones, the Boeing ones are also pretty cool. That they're gearing up for their own launch sometime in the next year-ish.
I mean, it's a tough thing to do because you need something that's flexible and maneuverable, but tough enough to hold up against vacuum, right? So it's a really complex part of the process, keeping humans safe in space.
All right. So everybody asked at least one question. Yes, good for everybody. Yes, this is the way the adult school classes should go, right? I love that. Thank you all. Maurice, we're happy to stay on for a little while longer. If anybody has any additional questions, jump on in some more. Otherwise, we can just sort of wrap up and have a couple, I don't know, closing arguments, although this is not an argument or anything like that. Maurice, do you have something you want us to say or to know about as we keep the channel open, the chat open for any more questions that are coming in?
Yeah, anyway, it's open to anyone. Anyone have any questions, just chime in. If you want to just chime in, either you can put in the chat window or you can unmute yourself and ask if you want to. It's up to you. A question I had was, you talked about the militarization of space earlier, Charles, and I know the last administration, presidential administration, created a fifth branch of the military too. It addressed exactly that. So what's your opinion of the Space Force?
Well,
do you mean the
Alan?
TV show or the?
Yeah, the actual.
Either one, right?
Let me tell you all that Alan has on a YouTube video explained the Space Force in great detail and has done a lot of work on it. So I think Alan understands much better
specifically
than I
about
do.
the Space Force. I made a video about that mentioned the Space Force sort of as part of itself. I guess it wasn't explicitly about the Space Force.
Oh, yes, including its provisional anthem.
Yeah,
right? Along with like Anchors Away, da, 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 and like on the halls of Montezuma, there is now a tentative Space Force theme song. It sounds something like na 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 na. We're the Space Force.
Yeah.
Something like
it doesn't
that.
actually have words, but I made the words up because it's just like part of some Sousa march, but it should have the words.
That's a great question, Maurice. And what I'd like to do is I present my opinion. I don't, and Alan and I disagree about this. So I want Karen to sort of weigh in and break the tie in terms of what the goodness of the Space Force is. I do not think the Space Force is necessary or appropriate yet. Maybe someday. But the thing is, the US Space Command is part of the US Air Force already and has been doing a really great job about the military aspects of space as far as the US military is concerned. I feel like adding that extra branch is unnecessary and comes with its requisite wastefulness maybe or extra bureaucracy that is really not that necessary. And I would rather see, say, Enderg put on, say, the US Cyber Command, which is a real and legitimate military situation right now, especially asymmetric, as opposed to something like Space Command. But Alan disagrees with me, so I give you the floor, Alan, to do the counterpoint.
Yeah, so I think it actually makes sense to split the Space Force off. So same way that the U.S. Air Force was originally the U.S. Army Air Force, and then was part of the Army, and then it split off into its own thing when air travel technology became sufficiently developed and a sufficient part of combat doctrine that it needed its own department to manage itself. I think that space is getting to that point as well. I think that we have space assets that were part of the Navy space assets. We had space assets that were Army space assets, that were Air Force space assets. And I think it makes sense. So if these satellites that are flying around doing reconnaissance and doing communications and all of that, I think it makes sense to have a dedicated service of the military to manage all of that because it's as important of a region as the air or the sea or the land at this point is managing those space assets. And I think that, as much as the militarization of space has its own problems of not wanting to spread this militaristic attitude that nations have toward each other out into another realm, I think that to some extent it's already there. And if we're going to want to use the resources that we have most efficiently, I think that it makes sense to have a dedicated space force at this point.
So, Karen?
Yeah, I don't really have a strong opinion about this. I mean, as Alan said, it's space has always been used for military purposes. I think as soon as people realized you could put things in orbit above other countries and look at them, they got excited, right? Or scared. Sputnik, I think, was the first thing that scared people. In terms of the bureaucracy and management of that, I don't really care if it's split up into different sub branches of the military or in its own branch. I mean, it's kind of amusing that there's a Space Force. A little bit, sorry, everyone. But I find that it amuses me a little bit, and I enjoyed the comedy series which explored that.
Okay, Dean, thank you so much. We'll do a follow-up at some point in the future. I think there's just one last question here from Jeff Opera Addict. Thank you. By the way, I don't know if you prefer Verdi operas or Puccini operas or maybe Alban Berg's Wozzeck, but I'm all opera. Good job, everybody. Thanks, Jeff. Let us know. What's the next book going to be? I think we all have some projects going on. Alan, Karen, you guys want to talk about your projects? I mean, I'll mention that a book that is in the works right now is a book about the entire history of the universe, starting from the Big Bang all the way into the future when the Earth is long gone and maybe all the stars too. So that's sort of a through line book that's happening with, again, beautiful illustrations and things like that. That's coming hopefully in about a year. Things got slowed down because of the pandemic, but the press, Ivy Press, is very good. They have great people. So hopefully that will come out sometime in our lifetimes and maybe even next year or late this year. So that's what I have to report. Karen, Alan, anybody?
So I've been working on a book about the connections between understanding gravity and learning about the universe. So how we've used astronomy to learn about gravity and gravity to learn about things in the universe. So that's been fun to work on. I don't have a particular publication date that I can tell you about yet, but it's starting to take shape as a real book. So we'll see what happens with that.
Cool. And Alan, would you like to share your?
Yes. So I guess the biggest thing that I'm working on that you can actually take a look at some point soon is I'm continuing to make YouTube videos. So I'm Signore Galilei on YouTube. I can put that in the chat, I guess. And I just make little few-minute videos about topics like the Space Force song, topics about things like Unicode and how the way that our computers understand language, just short things like that. You can take a look, you can not take a look, you can do whatever you want with that. I've also been doing some independent writing stuff, but nothing that's in any sort of publication pipeline at this point, but might be at some point.
That's the 21st century for here's Karen and me, right? 20th century people writing stuff onto paper when Alan, the 21st century person amongst us, really understands the way to reach the audiences through the electrons.
Well, I think they're both very helpful in the different sub bits of it all.
It's true. When there's a power outage, you're in charge.
Yeah, or if you want to just take a sit down and peruse something versus to.
Do you write on paper, Charles?
Do I write on paper? Yes, I still use paper.
Really? Okay.
Yeah.
I'm definitely a bridge here. I'm going with being the bridge. I might be writing, but it's all happening electronically.
Okay, well, there you go. At least I'm not using my manual typewriter.
Oh, yeah.
Well, I guess we're going to wrap things up. Thank you all for coming, especially our three guests here. We'll include links to the book, links to the book, emailed out to everybody to 30 Second Space Travel. We'll also include links to Alan's YouTube videos, if that's okay. And yeah, thanks everyone for coming out. Thanks for the questions. And we look forward to welcoming Charles back as well as the rest of you in the near future. Whenever you guys want to speak to us, we always want to hear from you guys. You guys a lot of fun, and we all love space travel here, or space, astrophysics in general, astronomy in general. So you always welcome to have you guys back here at the library. So enjoy the rest of your summer, everyone. We'll talk to you all soon. Any last comments for anybody on the panel?
Well, thank you, Maurice, and thank the adult school. You know, I know that we may all be old hands at the adult school, but this has been a great organization. It's lived for many, many decades in Montclair, and now is a part of the Montclair Public Library system. It's great, and I'm really glad that you're at the head of the ship and keep us going. So let's do this again and often. Thank you.
Yeah, you guys make it all possible. Thank you. Take care, guys. Enjoy the rest of your summer.
Okay.
Enjoy Florida too, you guys. Take care.
Thanks. Bye.
Bye.
Gonna head off.